So we've been looking at this idea of looking for a correlation between two quantitative variables. And this is one example. We were looking at this square footage versus house price info. And now the question is, how can we test the significance of what we're seeing versus, is that because in reality, in the population of all homes, is this the case? Or is this just a freak chance from our, variability of samples, as we've always done? So what we think of is a population parameter, right? We usually state our hypotheses in terms of a population proportion, which would be pi, or a population mean, which would be mu. So the statistic we have, remember, is R, our correlation coefficient. So from our sample, we compute an R, which is our sample correlation coefficient. And the theoretical value of, so if we had all homes, if we could put every single house price and square footage on there, there would be some correlation there. And sticking with the theme of using Greek letters for the population parameter, this is a Greek rho. Looks like a P when I'm drawing it, but it's a rho. The matching sort of Greek to Latin there. So this is our theoretical population correlation coefficient. That's a rho. So the question is, we're looking to somehow measure the likelihood of this occurring if there really was no connection, right? That's sort of the basis of everything we do, right? We assume, same thing we've done with differences in proportions or whatever. So say there's no connection there. So our null hypothesis would be that in reality, in the population of all homes, the correlation coefficient is 0. Remember, 1 is perfectly linear positive, -1 is perfectly linear negative, and as you move in towards 0, that is less and less correlated. And so that's our null position, that there is no association here. And so then our alternative, we could set this up a couple of ways. We could just do a very conservative test of, is rho not 0? Or if we wanted to, as we're looking at this scatter plot, the trend is positive. So maybe we would do for our alternative that, is it actually the case that rho is some positive value? So that's what we want to do. And we're going to do something similar to the idea of the past, right? When we've been looking at multivariable, the idea is to scramble things or break any connection in the data, and then sample from that over and over again to create your null distribution. So let's see how that works now in the applet. So I'm just going to use that house price data again. And we're just using the correlation and regression applet here, just like we did to generate a scatter plot. I'm going to paste my data in. So here's our square footage, house price. Let's show the correlation coefficient. So now let's move over here to our shuffle options. And we'll make this a little bit bigger here so you can see what's going on. Now we can test some different things here. I'll get into this other stuff later, but right now we're going to be interested in testing the correlation coefficient. So I'm going to check that box. And so let's click on shuffle and see what that does. Here's a scatter plot. What is that a scatter plot of? Well, let's go back over here to our data. All it did was scramble these prices, randomly scramble these prices. So now they're randomly connected to these square footages. And notice in our picture, there doesn't appear to be much of a trend anymore, right? Which is what you would expect because it's just randomly shuffled. Now, there could be a random situation where it looks a little more linear, and that's the idea of random variation. We could look at the data as well. There's the actual scrambled up data. Shuffle again. And each time we shuffle, a correlation coefficient is being computed. Sometimes, notice that R comes out positive. Sometimes it comes out negative. And it's just sort of randomly fluctuating. And then over here on the right, it's keeping track of all those correlation coefficients. Let's throw in 1,000 shuffles. Another 1,000. Another 1,000. So far we've done 3,000 shuffles. And look what we're seeing. Should have been very familiar to us. This is a nice symmetric bell-shaped distribution. Not sure if that's a t distribution or a normal distribution, but definitely we can look at that and see that we're getting something similar to what we've gotten in other null distributions. So let's remind ourselves what this means. If there was no connection between house price and square footage, and you just went out and grabbed some random houses over and over again, you might see correlation coefficients like this. Notice they're centered around 0 because since it's just shuffled, you would want on average, look at the mean of this distribution, pretty much 0. And it deviates either direction pretty consistently, right? Not any more positive than negative. What did we get in our data? Remember, here was our correlation coefficient, 0.78. So what would be the likelihood of that? 0.78. We will count that. And so far, we haven't got a single one in 3,000 shuffles. So this is a very significant p-value, right? It's rounding to 0. In reality, if you had done this millions and millions of times, there might be a few times it happened. But this is indicating that whatever that p-value is in the theory is very, very, very small. We could add some more shuffles in here, maybe see if we can ever get it to happen. My advice, though, is to not go much higher than 1,000. Notice at 1,000 shuffles, this is a little more complicated for the computer to do than what we've done in the past, where we could crank through maybe 10,000 shuffles at a time. But notice I click, and it's a good 5 seconds before it updates. If you try and crank this up to 10,000, you may have to wait a minute for it to update. So I don't think I would do that. I wouldn't go much higher than 1,000. But here we are at 7,000 shuffles and still has not happened. We have yet to get a correlation coefficient as large as the one that we saw in our sample. So this is providing some strong evidence that the correlation coefficient actually is greater than 0. There is some association here. Now, how strong is the association? This is our sample. We could, later on, we could talk about doing a confidence interval for rho. How confident are we that rho is 0.5 or 0.6 or 0.7? And we could build a confidence interval that way. But for right now, let's just stick with determining whether or not there is a positive association in this case. And this is very strong evidence that rho is definitely greater than 0. It would be very unlikely to get what we saw, or more extreme, if in reality house prices and square footage had no association whatsoever.